Okay, so multiplying, you do RC COLA. So I'm going to take that row times each of these columns. So this is what? -8 plus 0. This would be -2 plus 0. This would be what? -4 plus 0. Okay. All right. And then when I'm done with that row, I move on to the next one. So then I'm just going to cross this off. I have 5, 4. And you can just use a piece of scratch paper. All right. And then you take this row times every single column. So this middle one is 20 plus what? 4, 24. This one is what? 5 plus -8. So what is that? -3. This is what? 10 plus 12 is, what is that? 22. Okay. And then the last one that we have left is what? 6, -2. All right. And so what do I get here? I get 24 plus -2. So that's 22. I get 6 plus 4, which is 10. And I get, what is it, 12 plus -6, which is 6. Okay. And then it says show your scratch work for the last row. So this is last row. And you can check this on Desmos by editing this. So call this A and B, and then take A times B, see if you're right. But on the test, I want to see work. Okay. All right, let's look at the next one. Find the determinant. And again, the symbol for that is that. Okay. 2 ways. Okay. Not everyone did 2 ways. I didn't, really take off for that, but on the test, I will if you don't do it 2 ways. So I'm not going to do row 1. Do you see how it's has a lot of numbers? I'm going to do row 2 and row 3. All right, so let's do row, and again, I should probably cover that up. Okay, so say I do row 2 is what I'm expanding. So I have 1, -1 to some power, and then a determinant, plus 0. I'm not even going to write it. Plus what? 3, a -1 to some power with a determinant. Okay, if I'm doing 1, what is that? That is row 2, column 1. That adds up to 3. So this will be 4. This guy's going to be 5. All right. The determinant is what we call the minor. So if I'm at 1, I would cross off that. And my minor is what? 4, 4, -3, 0. And we're skipping the 0. And at 3, I'm going to cross that off and that off. So my minor is what? 1, 4, 0, -3. All right, so let's do the math. This is going to make it negative because negative times negative times negative. This is going to be what? 0 minus, be careful, -12. So -1 times 12 is -12. Plus, that's just going to be 0. This is going to be what? Negative, because the odd number, -3. And then when I do the determinant, this is what? -3 minus 0. So this part, isn't going to do anything, right? So that's going to be what? +9. I get -3. All right. That's one way of doing it. All right. The other way, there is a trick you can watch where you kind of rewrite 1, 1, 0, 4, and then you do this kind of dot, 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 dot. If you watch that YouTube video, I'm just going to expand this row because do you see how pretty that is? Oh my gosh. 2 zeros, yay. All right, so I'm just going to do that one. So I'm going to do row 3. All right, so what do I have? 0, I'm not going to do any work. -3, -1 to whatever power with a determinant, plus 0, I'm not going to do any work because it's going to equal 0 anyway. So really, I only have to do this middle one. All right, where am I? I am at row 3, column 2, so that adds up to 5. And then my determinant, if I'm right there, the minor is going to be 1, 1 below it, 4, and 3. All right, so what do I get? This is an odd, negative, negative, negative 5 times. So a negative times a negative, that's going to be a +3. And then when I cross multiply, all right, did I lose something? Was that +3 or negative in my formula? That was -3. That's okay. All right, so what do I get? I get 3 minus 4. All right, so then that is 3 times a -1, and that is -3. So yay, I get it both the same ways. I can also type this in as a matrix, okay, on Desmos, so I can make this a 3 by 3, and then you can pick the determinant of A, and you can check your answer, but you do have to show work. All right, okay, let's look at the next part. Yeah, I said elimination here, but the direction. So if you did elimination or Gauss-Jordan pivots, either way, I gave it to you. Some people, the negative disappeared, so you did 15 and got ugly fractions, and I apologize for that. It can happen, but it wasn't supposed to. All right, so let's do the Gauss-Dürr, or just do elimination. So you make these guys, what, 6 and a -6? So I'm going to multiply by 3, 3, and 3, and then -2, -2, -2. So I get 6x, 15y equals -45. Then -6x, -4y equals -10. These cancel, and I get 11y equals what? -55. Divide. I get a -5 for y. And then to get x, you just sub it back in. So some people like to do it again and cancel the y's the next time, but really can just sub in. So I get 3x plus 2, -5. So you're just subbing that into the formula. Then you get 3x minus 10 equals 5. Add the 10 to both sides, because again, you isolate an inverse. Divide, and you get 5. Okay, so x equals 5. So the answer would be 5, -5, or x equals 5. Now, if you did the Gauss-Jordan pivots, or you should be able to do these on the test, okay, is you make a matrix, which is 2, 3, 5, 2, -15, 5. Okay, it is this process. The only difference is you don't write the x's and y's, because I know these are the x's, I know these are the y's, I know these are the answers, okay, because I put them in order. So what you do is your pivot is always there first, then there second. All right. In the real one, you get a 1, but in the fake one, you do it just like this. You just don't write the x's and y's. Don't make it hard. All right, so look, 2 and 3. 2 times 3 is 6. You want 6 and a -6. So I'm going to multiply again, just like I did up here, the top one by 3 and the bottom one by -2. All right, so same as here. Now, the only difference is your pivot row is permanent, so you can't really change it. Like here, you can really change it, but in matrices, the pivot row is permanent, but you can change it on scratch paper. So I have 6, 15, -45. See how that's exactly the same? Down here, I get -6, -4, -10, exactly the same. It's just you don't write the x's and the y's. That's it. Don't make it hard. 0, 11, -55. See how that's exactly the same? All right, now your pivot moves here. This is your permanent, so I'm just going to rewrite it. Okay, on scratch paper, so instead of subbing back in, you actually do another pivot. That's a little bit different. So again, just look at these, 11 and 5, 55. So one of them needs to be negative, one positive. So I'll multiply this by, say, a positive 11. So what is that? 22, 55, and -165, I think. And then I'm going to multiply this guy by -5. Now, if it's already negative, sometimes you don't need to do that. 0, positive 55, and I don't know what that is. Let's see. Oh my gosh, what is it? 55 times 5, is that what I'm doing? Okay, 275, and is that, what am I doing? This one? Yeah, and that's positive. Okay, so then I get 22. Oh, what happened here? Negative. All right, because -5, negative. Yeah. All right, these equal 0. And then here, if I take 275 minus, what is that? 165? 110. Sorry about that. I had to deal with my phone there a little bit. All right, so this is my new row up here. Right, and then in this method, you get ones at the end. So just divide by 22, 22, 22, and you get 1, 0, 0, 1 eventually. That's going to equal positive 5. Divide by 11 to get a 1 there. That's my -5. So you can see I still get x is 5 and y is a -5. Same answer I got with this method. It's just a different method. Cramer's method will also give you an answer. So Cramer's is you find the determinant. Now, your determinant is just the coefficients. These are your main determinants, no x's or y's. So D, what I like to do is I like to write it 3 times. So 2, 5, 3, 2. The ones I highlighted, those are the coefficients. Then I write D again, 2, 5, 3, 2. Then I write D again, 2, 5, 3, 2. Okay, now obviously we don't need D 3 times. We need dx, which means you're going to ditch the x and replace it with the answers over here, -15 and 5. So put a -15 here and a 5. Same thing here. dy means you're ditching the y and going to put a negative 15 and what is it? Positive 5 there. Okay, so now you're going to find all three determinants. So this is what? 4 minus 15 is a negative 11. This is going to be negative 30 minus 25. That's negative 55. This is 10 minus, be careful, negative, what, 45? Positive 55. You got to kind of watch that double negative. All right, now to find the answer, x is going to be the dx. You care more about the x thing than the normal one. So negative 55 divided by negative 11 is a positive 5. X is a positive 5. All right there. And then dy, it makes sense to find y. You'd use dy over the normal d. dy is 55, and my normal d is 5. Oh, what am I doing? Okay. Oh, I see. Sorry. Looking at the wrong stuff. Julie. Okay. So dy is 55. My normal determinant is a negative 11. That makes sense. More sense. Y is a negative 5 right there. Again, same answers I've gotten all the way through. All right. The last one, the A inverse B method. This is my least favorite of all methods. A is your coefficients, just the coefficients of the beginning. So what is that? 2, 5, 3, 2. X is just your variables, X and Y. That's your variable matrix. B is your answer matrix, negative 15 and 5. All right. And then on a calculator, on Desmos, you edit A, edit B, and you just do A inverse times B. Okay. All right. I will pause here and I will get Desmos up quick for some of these that you want to see on Desmos. Okay. The A inverse B one, let me just show you that one quick. 2, 5, what is that? 3, 2. You don't type in the X matrix because that's just variables. And let's see, this is what? 2 rows and what? 1 column. All right, so this one's the answer matrix, negative 15, 5, enter. And then this is the A inverse times B method. And there's your X and Y. Okay, I like just typing the whole thing in and doing reduced row echelon form. Okay, let's look on, well, I have a little bit of time. Let's go back to the first page. Let me just clear everything here. If you want to check your multiplication to see if you caught an error, okay, so I could do let's see, new matrix, and I could do, what is this? How many rows? 3 rows, 2. So I could enter, this is problem number 1, and I kind of erased, or I crossed stuff off, so hopefully I'm okay. Tab 0, okay, tab's not working. All right, we'll just do this. 0, and then what was it? 5, I think 5, then what? 4, and 6, then negative 2. All right, enter. All right, and then we're going to do B, and let's see, what do I want this guy to be? RC column, 2 rows and 3 columns. All right, so this one is 4, 1, and what? 2. And then what's the bottom one? 1, negative 2, 3. And again, I think it's easier just to do these by hand than it is to type them into Desmos personally. I think it's easier. All right, so I'm going to just take what? A times B. And again, order matters. They're not commutative. All right, and I can check my answer. Hopefully, did I make any dumb mistakes? It doesn't look like it, so that's good. All right, now I'm going to check the determinant of that big one. Okay, so let's do A. Now it was what? A 3 by 3. All right, I'm going to see if I can get the tab to work to make it easier to type. 1, 4, 4, 1. Oopsie. What was that? 1, 0, 3, and the last row is 0, negative 3, 0. Okay. All right, and then I'm just going to go to the end here, hit enter. All right, and I just want the determinant of A. See how it gives me my negative 3? Yay, that's good. And then on, let's see. I mean, on the pivots, I mean, if you want to do reduced row echelon form, I mean, I can clear this. You could do our number 3. You could do, what is it, 2 rows, 3 columns. Again, you could enter the 2, the 5, negative 15, and then you could do the 3, the 2, the 5. hit enter. And then when you do the pivots, it's called reduce row echelon form of A. And see how it spits out the ones